Hi, I'm Andrew Spivey, Senior Analyst at ABI Research. Our new spotlight covers the key trends, data points, and the competitive landscape of the wireless LAN campus networking market. Here's what the industry players need to know. Enterprise-grade wireless LAN access points, otherwise known as APs, are the technological backbone of campus networks. Shipments of these APs are forecast to more than double between 2023 and 2030, rising from just over 20 million annually in 2023 to above 41 million in 2030. This translates to a $20.9 billion USD market opportunity for wireless LAN equipment vendors, network management platform providers, and value-added service suppliers. As just mentioned, the total market value for all enterprise wireless LAN APs will be over 20 billion annually in 2030, double the value today. However, the rate of growth will vary significantly by vertical. Of all the campus verticals, industrial manufacturing will witness the greatest rate of growth throughout the rest of this decade. This growth is fueled by wireless LAN expansion, thanks to tech advancements broadening its use cases alongside rising factory automation. There are 4 applications for AI in wireless LAN networking which I believe are particularly promising. The first is large language models, which can support administrators with network management. The second is the expansion of root cause analysis into application monitoring, helping to precisely pinpoint the cause of network issues. The third would be AI-driven automated radio resource management for more efficient allocation of radio resources. And the fourth is digital twin simulations of the network, which can enable administrators to further optimize networks by testing out new topologies and automations before deployment. That said, I would caution that companies must ensure that they are targeting their implementations of AI at solving specific business challenges, and they aren't just deploying AI merely for the sake of AI. The open source disaggregated architecture of Open Wi-Fi brings with it many benefits, including management simplicity, lower costs, and interoperability between the hardware from different vendors. Yet, despite these positive attributes, adoption to date has been slow due to a combination of resistance by large wireless LAN incumbents, a lack of clarity over who will take ownership of system issues, and hesitation over implementing a new technology. Alongside this, open source approaches will be especially challenging in campus environments, as many specialized optimizations not found in the open source code are required. Network as a Service, or NAS, is a new service model that allows campuses to outsource the operation and maintenance of their network to a managed service provider for a subscription fee. NAS migration in campus has been slow, but there are methods to stimulate adoption. One such method, which would be particularly attractive in the hospitality and retail sectors, would be 2-tier NAS packages. These essentially allow campus networks to take a portion of the network which their managed service provider is managing and to sublet this to another third party, which would create additional revenue opportunities for the campus network. The education vertical offers the largest total addressable market today. This is due not just to its sheer size, but also the many funding mechanisms available for network deployments and upgrades. One example is the E-rate funding mechanism administered by the FCC in the US. Industrial manufacturing is the vertical projected to undergo the fastest growth in the coming years. The second fastest growing vertical is forecast to be large public venues, where challenges such as increasing client density, client roaming, and real-time streaming requirements will make network upgrades necessary. The following are some of the key trends in campus networking. Firstly, we have the rise in the number and diversity of client devices, creating a higher density of users in the network. This in turn exacerbates spectrum congestion, something which highlights the urgency for additional spectrum and improved spectrum efficiency technologies for campus networks. Secondly, we have new performance demands: ultra-high latency, high throughputs, fast roaming, indoor positioning, etc. Migration to the latest wireless LAN technologies is necessary to satisfy these demands. Finally, we have strained budgets and resources, and challenges sourcing qualified staff. To assist with these, AI automation and new service models like Network as a Service are key.